Okay, this is Hey. Today I would like to do a review on one of the WebWork problem. WebWork problem 5, question 2, problem 2, and stated that a tank contains 60 kg of salt and 1000 liters of water. A solution of concentration 0.03 kg of salt per liter enter a tank at the rate 5 liters per minute. The solution is mixed and drains from the tank at the same rate. So, what is the equation for this? We can find. Let's go on and see what is given to us. We know that the initial value of salt, the initial amount of salt is 60 kg. In 1000 liter. So it's gonna be .06. Let's see if it's right. I think it's right. Yep. So this is gonna be 0.06 kilogram per liter. That is the initial concentration. And what do we know? We know that's the input rate. The input rate is 5 liters per minute with 3 kg of salt per liter. So input rate equal 0.03 kg per liter time 5 liters per minute. So that's our input rate. What is the output rate? So the output rate is say that a solution mix and drain from the tank at the same rate. So we know that the output rate is 5 liters per minute, but we don't know what is the concentration, and we're gonna find out, and we're gonna set output rate equal, and the A is gonna be the amount of salt in kilogram, and it's mixed with 1000 liters. Time the amount is going out 5 liters per minute. So what is the equation of the mixture solution? So we're gonna let dA dt, that's the rate of salt with respect to time, equal to input rate subtracted by output rate. So what is our input rate? Input rate is this right here. So it is 0.03 . and output rate. So we're gonna solve for it. It's gonna be 5315.15 minus, we can forget about the units in here, minus the output which is 5a over 1000, which is 1 over 200. So in here we know that this is the equation here is the non-homogeneous. So what we're gonna do, we're gonna let this equal to px in here. P of x. I don't know what to write it, px. So it's gonna be t equal e to the integral of px, which is 1 over 200 t, and that's gonna give me e to the 1 over 200 t. Then we're gonna plug it back into the equation, and what's we're gonna get 1 over 200 1 no e to the power of 1 over 200 t dA dt plus 1 over 200 a e to the 1 over 200 t equal 0.15 e to the 1 over 200 t. So what we did was we take this and multiply to this equation right here. So by looking at this, we know that this is the products rule. We're using the products rule. We know that's equal to d dt equal to let's say it's gonna be first time derivative of second, and second time first time the derivative of second, and second time derivative of first. Either ways, so it's gonna be a e to the 1 over 200 t equal 0.15 e to the 1 over 200 t. So a e to the 1 over 200 t equal integral 0.15 e to the 1 over 200 t dt. And now, what is the integral of this to time with respect? So that's equal to 200 times 0.15 e to the 1 over 200. Remember, e to the t is e to the t, and its coefficient is gonna be the same. So it's 200t plus c. And I'll write this down to a e to the 1 over 2. So I need another page. So we're going to divide by e to the 200t. We're going to divide this by e to 200, 1 over 200t. So that's going to give me a equal, so this is going to be 30. This is going to cancel out, so it's giving me c over e to the 1 over 200t. Now we're going to find the c, the value of c. How are we going to do that? We're going to use our initial value, which is given to us, 60 kilogram of salt at time equal 0. So at t equals 0, a equals 60 kilogram kg. So 60, we're gonna plug it in, 30 plus c, and we know that e 1 over 200 times 0, that's gonna go to 0, and e to the power of 0, any number to the power of 0 is gonna be 1, and what we're gonna have is 60 minus 30 equals c, which is c equal 30. So what is the general solution? It's gonna be a equal 30 plus okay, let's test this out, whether it's right or wrong. Okay, whether it makes sense or not, let's see. So what happened if we set t equal to 0? At t equal to 0, what happened? T equals 0. T equals 0, this whole thing is gonna be 0, and 30 plus 30, that's gonna be a equal 60. Makes sense, right? So what happened if t go to infinity? We set limit a at t, and let's call it a at t, equal limit t go to infinity, 30 plus 30 over e to the power 1 over 200 at let's say big number, right? It's gonna be infinity, can be n number, and when this go to infinity, what happened is we got a huge denominator in here, so small number divided by big numbers, that's gonna go to 0. So the whole thing is gonna go to 0. So the at gonna equal to 30. So we know that at times increase goes up more and more, this amount of salt is gonna approach 30 kilogram kg. So it's gonna be 60. So visually, this the graph gonna give us something like this. I have to visual. It's gonna go 30 over time. So it's gonna be something like that. It's approaching 30. So The question B saying that find the amount of salt in tank after 1.5 hour. So we're gonna 1.5 hour, that's 60 minutes. No, that's 90 minutes. So let's see, A at 90 equal 30 plus 30 over e to the 1 over 200 times 90. So let's use a calculator. Say E to the power 90 over 90 divided by 200, that is 1.5. So 30 divided by this number, I get 19.12. Got 19.12, and if I add it with 30, that's got 49.12, so 49.13 if I round up. Kilogram of salt. So this 49.13 kilogram of salt. So find the concentration of solution in a tank at time approaching infinity. So we did that in here. We did that in here. So this is gonna be the C. Yeah. And this is gonna be our B, and we did this A separately. And I think that was it. Other than that, it's gonna be, this is gonna be approaching 30. So I think that's it. Alright, hope this is helpful.